Okay, so today we have Edoardo giving us a simple overview of an interesting paper written by people at Microsoft, which is called BIT and is used for essentially applying some self-supervised learning techniques to the audio framework. So, yes, Edoardo, please.
Thanks, Giacomo, for the introduction. Um, as Giacomo said, I'm gonna explain what is the self-supervised learning, and then we take a look to the BIT framework. The question is, what is self-supervised learning? So in simple terms, is a learning process where the system is trained to anticipate a part of the input data from other section of the same data. So this means that like traditional supervised learning, which relies heavily on labeled data, for self-supervised learning, those amount of data is of labeled data is not necessary. So the secret of the self-supervised learning lies in the ability to learn representation by predicting certain aspects of the data that is fed to the model. So let's delve into why we should consider self-supervised learning as a cornerstone of the modern machine learning practice. So the first advantage is the ability to significantly diminish our dependence on large volumes of labeled data for the model, as I said before. We know that it's very difficult to obtain a big amount of labeled data because it can be resource intensive and often require also human intervention if we need an accurate classification. So later on, there is the aspect of the domain adaptation. In fact, this aspect empowers to learn generic representation and not just specific ones. So we can then later fine-tune to perform optimality in different scenarios or tasks. So what are the use cases of this technology? So the first one is the language modeling. In fact, one of the most common example is predicting the next word in a sentence. Here, the models learns from the context. So the continuous feeding is like understanding back in the process to improve the prediction. So we take the result and give it back to the input of the model. So secondly, there is the audio tagging that is our cases, and here self-supervised learning is like that involves to assigning relevant tags to different sound. This is based on the content of the audio itself. So the self-supervised learning here enables a rich and meaningful representation of the audio data. And the model becomes more, I'd say, more better, becomes better to, for example, identify generic patterns. And this knowledge can be fine-tuned to adapt to specific tagging tasks or providing more robustness against, for example, noise in the audio data. So finally, we have the computer vision. That is a common task for this technology. For example, predicting the missing part of an image or a color of a pixel based on the surroundings pixels. So this new framework presented in a paper by a Microsoft team. So BITS stands for bidirectional encoder representation for audio transformers. And this is a model that is crafted to generate representation for audio data. And the novelty here lies in the innovative application of the transformer architecture, which until now has been primarily used for text-based tasks. Like for example, right now, the new ChatGPT is based on transformers. So quickly, what are the transformers? Are models that work based on a mechanism that is called attention. And this allows the model to weight the importance of different inputs when producing an output. So this approach empowers bits to learn from audio,
So sorry to
operating on,
interrupt.
yeah.
Maybe just to give a little bit more context about this thing of transformers, the idea is that it is able to capture a relationship between things that might be far apart in the data. So if you have a text, you might be able to, find the relation between, I don't know, a noun given at some place and then the corresponding adjective that could be given, a few words later or something like this. And similarly for audio, so it could relate maybe something that you find at the beginning of the audio with something that comes after a while. So the idea is not does not just look at the local information, but in some sense has some global idea of what's going on. This is true for audio, for images, for text, most importantly. So yeah, just okay. Sorry for
Yeah,
interrupting. Just
exactly. No problem. Thank you for the delucidation. So I was saying that this model predicts parts of the audio from the rest. So this enables to learn and understand the complex pattern and structure inside the audio domain. So, but what are the application of bits? First one is audio tagging. In fact, bits can be very efficient in this task. So here the model can label different parts of an audio file, and can also, for example, categorize music genres or classify speech, detecting also various environmental sounds. The next one is the speech recognition. That's like right now it's a very great stride in the world of voice technology. In fact, the model can convert spoken words into written text with a very high degree of accuracy. Lastly, we have audio generation. In fact, with different technique of training, this model can also create new audio samples. So quick overviews on the performances. This model sets a new state of the art in the audio tagging tasks. This is reached on different data sets that are renovated for the task of audio tagging. So this was a quick introduction on self-supervised learning and bits. Thanks for your attention.
Thanks, Edoardo, for a nice introduction. I well, I don't know this one. I think was pretty straightforward. I don't know if Joanna and Bruno, you have any questions that or any clarification that you might want to ask to Edoardo.
Well, I have a question of pure curiosity. Um, I suppose that this, as you were mentioning, this self-learning process, some may be in some cases more or less accurate, and may sometimes don't give the same result as other methods, other used methods. I want to know if there are some sort of data that are more likely to be that fits best this kind of method of self-learning.
Starting from the point that the data shouldn't be labeled, I can say that if the data are more homogeneous, like also in balancing of the various classes, I think that this can be helpful for the training process.
So for example, the performance is the same if we consider uh, audio data or images, for example, or text, or there is some evidence of different performances.
I think that is quite the same. The performances maybe on the text is more powerful because um, the transformers in the text are very important because can really understand the relations between words. So maybe on text the performance I can say that that are slightly better respect to the image, for example.
Maybe I just wanted to add a comment. Not sure if it's 100% correct, but when it comes to audio and images, they in a way they are the same thing in the sense that the audio is always turned into an image, so into a spectrogram that is then fed into the network, and that could be the case for beats, but also for other architectures. So in some sense, they are the same. So there is always a visual counterpart in both audio and actual pictures. And probably the other thing worth mentioning is that when you have these unsupervised methods, I think you want or self-supervised, you want a lot of data unlabeled, and it's usually much easier to get a lot of text just by scraping things from the internet. I don't know if you had a look at what the OpenAI guys did. Essentially, big chunk of work is scraping the internet, so it's easy to get a lot of text. For instance, images are probably a little bit more rare, I would say, or even audio. So there's plenty, of course, maybe just a little bit more difficult to obtain, which is not really an answer to your question in the sense that your question was more like thinking in principle if there is any advantage, but there is probably some difference in gathering data. Joanna, you have any questions or?
Maybe just one, which is a really straightforward question, but maybe the answer is the need for so much like tagged data. But since supervised learning seems so effective, why would you use an alternative?
Um, I mean, yeah, it is effective, but here we are dealing with the problem of unlabeled data. So in the case, for example, if we have tons of labeled data, there is no reason, obviously, to do a self-supervised approach instead of classic supervised approach. So if we have data available and that are labeled, you should use a supervised approach, and the performance would be always better with respect to a self-supervised approach.
Okay, guys, I think we discussed for 15 minutes. So thanks a lot for for the presentation, Edoardo, for the questions, Bruno and Joanna. I will see you in the next episode.